Welcome to a lesson with Dr. Powell. Let's talk about a notation that we can use to express the idea that we want to add up all the terms in a sequence from one position to another. In order to do this, we need two things. We need to know what the formula for the sequence is, which is the same as knowing what the pattern is. We need to know what the pattern of the sequence is, which is the same as the formula for the sequence. Like A, so formula, okay, which is the same as A sub n is equal to something. We also need to know what positions we're going from. So we're going from, the positions. Going from 1 to this, or 2 to this, or 3 up to like 13. So n equals one position to n equals another. So for instance, we could go from n equals 3 to n equals 14 even. Let's do that. Okay, so knowing those two things, that's enough, because that's all we really need to know what we're adding. We know the formula, so that gives us the sequence. We know the positions. Okay, now how do we put that in a notation? We use this letter. It's a letter? It's a Greek letter. It's a Greek letter sigma, which stands for sum. Does it look like an S? Not yet, but just use your imagination. Just kind of remove that line and kind of round the corner there. And that one, it's an S. So we are summing up, adding things up. So this symbol is used often in mathematics, and it just basically means add. It means sum of a list of things. That's really all it means. So we use this symbol to mean that we're going to add something. So we put our pattern or formula right here. For instance, let's suppose that we have A sub n is equal to 2n plus 1. So we'll write that 2n plus 1. And now suppose that we want to go from position 3 to 14. We notate it this way. Our beginning position, we write below the symbol, sigma. So we write n equals 1. And this just emphasizes that we're using the variable n here for our sequence. And then we just write a 14 up here. We don't write n is equal to 14 up here. We just write 14. So we'll use this n equals to go for both of them. So 1 to 14, if we were starting at position 1. Now, in this particular case, I think I wanted to start at position 3. So we'll write a 3 down. So go from position 3 to position 14 and add up all the terms from those positions in this particular sequence. We could actually write this out even. Let's think. At position 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. At position 3, let's say we plug it in, because n means position, plug 3 in for n. So 2 times 3 is 6, plus 1 is 7. Now, instead of plugging all these in, let's just remember that the slope of this as a line is 2. So that means we're adding 2 each time. So this is like 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus 23 plus 25 plus 27 plus 28. Whew. Okay, so for each one of these. All right, wow. Okay, so that was a lot to write out. This right here is a simpler, quicker way to write down the sum that we just wrote out. All right, now we could actually use our technique for adding up arithmetic sequences here. We take our first guy and our last guy, and we add them. 7 plus 28 divide by 2. That gives us the average of the whole thing. Then we multiply by how many we have. How many do we have? You may be tempted to say we're position 14 and 3, just subtract 14 minus 3, and there should be 11 things, but you would be wrong. Let's see why. Let's see. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 things to add. One way of thinking about that is, what if we just kind of drop the 3 down to 1, then you drop the 4 down to, so look, well, there was 2, right? You had to take 2 to drop the 3 to 1. Then the 4 would drop to 2 and so forth, and 14 would drop to 12. So it'd be the same as going from numbers 1 through 12. That means there's 12 things. So you take so one way of doing it is just to say, what do I have to add or subtract to the beginning guy to get 1, and do the same thing to the ending guy, and that's the number of terms that you have. So in this particular case, we have 12 terms. So I'll put a 12 right here. All right. So now we're off and away, and we can compute this. 7 plus 28 divided by 2 times 12 will be the sum. So we can simplify this. That's 6. And then here, 28 plus 7 is 35. So we have 35 times 6, which should be, I believe 200, is it 210? 210, let's see, 6 times 30 is 180, and then yeah, plus 30, so 210. All right, or it's, yeah. Okay, so we have our sum is 210, so that's what this symbol meant, and we just computed the sum. Thanks for watching.